Hey, this is Randy. Today we're going to learn how to multiply monomials by polynomials. Let's do this. So here in this first set of parentheses, we have a monomial, negative 2y to the fourth, times what we have in the second set of parentheses, which is a binomial, negative 4y cubed plus 2. So we need to multiply every term in this first set of parentheses times every term in the second set of parentheses. So in other words, we're going to distribute this negative 2y to the fourth, and then we will have our final product. So first of all, we need to do negative 2y to the fourth times negative 4y cubed. And in order to do that, we need to first multiply the coefficients. So negative 2 times negative 4, just like when we multiplied monomials. Same process there. So negative 2 times negative 4 is positive 8. So we're going to say positive 8. And then y to the fourth times y to the third. How do we do that? Just like we've talked about, we need to add those exponents. So 4 plus 3 is 7. So 8 times y to the seventh. Now we have a plus in this set of parentheses right here. So we're going to bring that directly down. We're going to say 8y to the seventh plus something. Now we need to do negative 2y to the fourth times 2. Okay, well, first of all, 2 could be thought of as 2 times y to the power of 0. We know that y to the power of 0 is 1. So let's keep that in mind when we multiply. We have negative 2 times 2 will be negative 4. So negative 4. And then we have y to the fourth times y to the 0 is like saying y to the fourth times 1, right? So y to the fourth times 1 is y to the fourth. So we have negative 4y to the power of 4. All right, very good. Now, we could simplify this even more because plus negative is like saying minus. So let's rewrite this with a minus in between the two terms. So we have 8y to the power of 7. Let's see here, minus 4y to the fourth. And we cannot combine any like terms here. So that is our final product. Let's do another example here. This time we have a trinomial in the second set of parentheses, so it'll take a little bit longer, but the logic is the same. So just as a review, we're going to do 3x to the 8th times negative 2x squared, and then 3x to the 8th times 4x, and then 3x to the 8th times 5. And then we'll simplify if possible, and then we'll be done. So 3x to the 8th times negative 2x squared. Okay, 3 times negative 2, those two coefficients, will give us negative 6. So let's see here. 3 times negative 2 is negative 6. And then x to the 8th times x squared, we add those exponents. So 8 plus 2 is 10. So a negative 6 x to the power of 10. Just like that. All right, now next one here, we need to do 3x to the 8th times 4x. So let's see here. 3 times 4 we know is 12. And we have a plus right here, so we're going to bring that plus directly down. So we're going to say negative 6x to the 10th plus 12. 12 what? Well, we have x to the 8th times, right here we have x to the power of 1, right? Even though we don't see the 1, we know there's a 1 in the exponent. So we need to add 8 and 1, which will be 9. So we have 12 x to the power of 9. And lastly, we now need to do 3x to the 8th times 5. So 5 is like saying, just like we did in the first example with the constant, this is like saying 5 times x to the power of 0, or 5 times 1. So eventually we're going to do 8 plus 0 is still just going to be 8. But before that, we need to do 3 times 5 is 15, right? So we're going to say, just like we have a plus here, we're going to bring that down. We're going to say plus 15. And then x to the 8th times x to the 0 is still just going to be x to the 8th, x to the power of 8. Now, can we combine any like terms here? We cannot. So negative 6x to the 10th plus 12x to the 9th plus 15x to the 8th is our final answer. One more thing to keep in mind on all these problems is that we want to write our final product in standard form. That is, with the exponents going in descending order. And in this case, they are. So there's nothing else that we can do to simplify this. And with that, we are finished with the video on multiply monomials by polynomials. And remember to always be clever.